Hello everybody, welcome back to my YouTube channel Izaz Data. In this video, I'm going to discuss about a science chapter 10 standard electricity. Without wasting time, let us enter into this chapter. See, this what is the exactly meaning of electricity? See, electricity is nothing but in this is nothing but a study of charges. Study of charges. So there is electricity. So there are two types of electricity. That is, one is called static electricity. What it is? Static electricity. And the second type is what? Current electricity. Two type of electricity. One is a static electricity, second is current electricity. In static electricity, you are going to study about the charges which are at rest. Study of charges at rest. And in current electricity, you are going to study about charges which are in motion. See, charges at rest, what exactly it means? See, in this, the example will come like, normally when we were, child, that we used to, during the classes, we used to play with our friends. We used to rub we used to rub the scale on our head, that is the hairs, dry hairs, and then we used to take that scale near the pieces of paper, and the pieces of papers were getting attracted. So that example comes under like pieces of paper are attracting towards the scale, correct? So that example will come. And another example like when we rub the balloon, on our head, on the hair, dry hairs, it gets stick to the walls, correct? So these are the example of static electricity. So exactly why actually happens, why it happens? See, when you rub anything on the like you are rubbing the scale on your hairs, so the scale is getting charged. And when you take that charge scale near another charge particle, then it will get attract, correct? It will get attract or it will get repel. So in the case of when we are rubbing a balloon on your head, and the wall is having one charge, balloon is having one charge, mostly opposite charge, so they are getting attracted. Understood? So charge in motion, what exactly the charge in motion, what it means charge in motion? So you know that like the conductors are metal, so they have a large number of many free electrons are there. So this the current in that conductor is due to this motion of this free electron. Hence this electricity is called what? Current electricity, because it is due to the flow or the motion or the movement of electrons. An example in this, you will get a metals like a copper, iron, aluminium, etc, etc, right? So now what is exactly the meaning of charge? What are charges? See, charges is nothing but it is a physical property. Charges is nothing but what? It is a physical property. It is a physical property of a matter. Like how matter is having mass, matter occupies, that matter is have a volume, matter occupies a space, nothing but a volume. In the same way, the matter is also having a charge. Okay, so it is a physical property of a matter. Because of this, it attract or repels. Okay, it attract or repels with other material. So there are two type of charge. One is called positive and another charge is negative charge. See, the charges, property of charges is that they repel if they are like charge. Like charges repel and unlike charges will attract. So this is the property of a charge, that like charges repel and unlike charges attract. Okay. So charge, the metal is having an electron, right? Metals are having an free electrons. So what is the charge on one electron? What is the charge on one electron? It is a standard 1.6 into 10 to the power of minus 19. And the unit of charge is coulomb. So it is one electron is having a charge of 1.6 into 10 power minus 19 coulomb. The unit of charge is coulomb, remember. Coulomb, coulomb. Okay. And this charge, it is denoted by Q. Charge is denoted by what? Q. And the charge on each electron is 1.6 into 10 to the power of minus 19 coulomb. Unit of charge is coulomb, and the charge is denoted by Q, remember. Okay. And how many electrons are there in 1 coulomb of charge? Matlab, like how many electron will make a 1 coulomb of charge? So we have a formula, that is Q is equal to number of electron, n number of electron. So if you want to find out that how many electrons are there in 1 coulomb of charge, so that is Q is equal to 1 coulomb, n is equal to question mark, and electron is equal to 1.6 into 10 power minus 19 coulomb. So Q is 1, n we don't know, and electron is 1.6 into 10 to the power of minus 19. So we'll just cross multiply this here. We will get n is equal to 1 divided by 1.6 into 10 raised to minus 19. If this 10 raised to minus 19 comes in the numerator, you will get 1 into 10 power 19 divided by 1.6. So you know that you can't divide it in the denominator, decimal is a, so you can multiply with a 10. Here it is multiplied with a 10, and here it is multiplied with 10. So if you multiply with a 10, you will get 10, 1 into 10 divided by 16, and this into 10 raised to 19 as it is. So, and if you want it, you can remove one power here and you can multiply with this, so it will become 100 and into 10 power 18 divided by 16. So if you divide it, 100 divided by 16, you will get 6.25, and this 10 raised to 18, this number of electrons constitute 1 coulomb. So, number is very big. 6.25 into 10 to the power of 18, it's more in number. So now if we go for a next topic, what exactly meaning of electric current? What is the meaning of electric current? What is electric current? Anyone knows? See, electric current, current is nothing but flow. Uh, like water current. Water current means what? How much water is, like, flow of water. Like a wind current, flow of air. So in the same way, electric current, nothing but a flow of charge. Flow of charge. Flow of charge. See, we want to find how much exactly the current is there, or how much electric current is there, then we have to consider that how many charges are flowing in unit time. So flow of charges in unit time. Flow of charges in it. How many charges are flowing unit time? For example, if I say in one wire, that is A, another wire, that is B, and in this particular, like here, how many charges are flowing in unit area, like this area if I make here, and in the same way if I make it here also in this area, how many charges are flowing through this unit area in 1 second, that will give you electric current. For example, if I say that through this area, you know you can say 3 coulomb of charges are passing in 1 second, and in this 7 coulomb of charges are passing in 1 second, then what is electric current? So here, how many charges are passing in 1 second, that will give you the 3, the current flowing through this is 3, and here the current flowing through is 7. How many charges are passing in 1 second? So where the current is flowing more, so here in the case of B, because here more number of charges are passing in 1 second. How much more charges are passing, in which case more number of charges will pass in 1 second, that constitute a more current. Hope you understood. So what is the formula? Electric current is denoted by I, and the formula flow of charges is denoted by Q. So charges, flow of charges in unit time, so divided by unit time is nothing but T. So this is the formula. I is equal to Q by T, and the unit of electric current is ampere. The unit of electric current is ampere, or even this is, this ampere came on the name of a scientist, okay, to honor a scientist who, who explain about this electric current. To honor him, this unit is to honor him, right? So another unit based on the formula. What is the unit of a charge is coulomb. What is the unit of a time? It is second. So you can also say coulomb per second is the unit of electric current. And by what device we can measure the electric current? Electric current can be measured by using a device called ammeter. What is the device? Ammeter. Okay, ammeter is a device which is used to measure the electric current. Okay, one more device is called galvanometer. Remember, it does not measure how much current is flowing. It just detect the presence of current, whether the current is present or not present. To detect the presence of current, galvanometer is used. To measure how much current is there, what is used? Ammeter is used. Remember, what is electric current? A flow of charge in unit time is called electric current, and the unit of electric current is ampere, or you can say coulomb per second. And now next topic is what is a current formula we got to know. Now what is exactly the meaning of 1 ampere? You know the formula of electric current, I is equal to Q by T. So we want a 1 ampere. What is the meaning of 1 ampere now? Anyone knows what is the meaning of 1 ampere? So you know that I want a 1 ampere, for example, here I want a 1 ampere. Then what should be the right hand side? See, if I have a 1 coulomb of charge flowing in 1 second, that will give me the 1 ampere. So what definition of 1 ampere will come? 1 ampere is nothing but a flow of 1 coulomb of charge. Flow of 1 coulomb of charge in 1 second is called as what? 1 ampere. Everybody understood? Flow of 1 coulomb of charge in 1 second is called 1 ampere. And remember, the current is measured by using a device called ammeter. And remember that ammeter is always connected in series. See, remember, ammeter is a device which is used to measure the current. It is connected in what? Ammeter is connected in what? Series with the circuit. Remember, it is like in detail about this we will learn when we will learn about series and parallel connection, but at present you remember A for ammeter, S for series. Ammeter always connected in series, remember, with the circuit. Any doubts? So this is about the electric current. If I give you one numerical based on electric current, then the first question, not a normal questions. See, 1.6 into 10 raised to minus 19 coulomb. 1.6 into 10 raised to minus 19 coulomb charge flows through a conductor in 10 power minus 10 second. Find current flowing through conductor. Find current flowing through conductor. So try. 1.6 into 10 to the power of minus 19 coulomb of charge flows through a conductor. So you can try. See here, Q is equal to 1.6 into 10 raised to minus 19 coulomb flows through a conductor. Time is given 10 raised to minus 10 second. Find the current. I know the formula, I is equal to Q by T. So Q is 1.6 into 10 raised to minus 19 divided by 10 to the power of minus 10. I is equal to 1.6 into 10 to the power of minus 19. 10 to the to minus 19, and here if it comes in numerator it becomes 10 power 10, positive 10. So you will get I is equal to 1.6 into 10 power minus 9. This much ampere of current is flowing. Okay, understood? So this much ampere of current is flowing through a conductor. Let us go for a second question. What is that second question? Let's see. How many electrons how many electrons pass through a conductor? in 0.2 second if the current passing through it is 0.5 ampere. So try. I think you can do it. How many electron passes through a conductor? See, they gave how many electrons, nothing but n is equal to question mark, time is equal to 0.2 second. If the current passing through current they gave I is equal to 0.5 amps. So you know that I is equal to Q by T, correct? So I want to find out n, right? So I can write this formula as I is equal to Q is nothing but you know Q n into E divided by T. So I want to find n. So this IT and this E will come here. N is equal to I into T divided by E.